Hello again. Today in our small groups, we're going to be doing kind of just some problems from our workbook pages. So you're going to need your workbook page packet that I gave you. Yours is in color, mine is not. I had to make copies of it. So you're going to need to have that, and we're going to be doing some problems starting on page 50 all the way through page 56, but we're not going to do all of them. So please don't do all of them. It's not necessary. We're just going to kind of go back through and review. And again, this is what I'm doing with the small group time. So have this in front of you. I did attach copies of it, or if you just wanted to write some of it out on lined paper and then put it with your workbook page packet when you get it, that's fine by me. The idea is just to make sure this is all fresh in your brain still, because we've had some time off and been quite a few absences and whatnot. So start off and open up your packet to page 50, page 50. And it should look like this. At the top it says represent numbers in different ways. I do not want to do all of these. I want to focus on number 3 and 4. So we're going to go right down here to number 3. And I give you this as, well, they give you this as an addition problem here. And it asks you for the standard form. So if you had 70 plus 2 plus 4 tenths plus 3 hundredths, I would have a 7 in the tens place, a 2 in the ones place, a 4 in the tenths place, and a 3 in the hundredths place. Word form of that. Okay, so remember we use this, that's our word and, right? So to the left side, I would read this as 72. So 72, that gets the dash. And remember when you see a decimal point, and then we're gonna read this number. What number is that? It's 43, so you can write 43. And it's 43 what? To figure out 43 what, you look at the last place to the right of the decimal point. What place is this 3 in? Tenths, hundredths place. So I would say 43 hundredths because the 3 is in the hundredths place. And again, that is 100 with a thus. So 100, thus, hundredths. Okay? Then I want expanded form with the place values. So this is expanded notation. That's what they mean with the place value. So if I wanted to write this using expanded notation, I would write each digit times the place that it is in. So this would be 7 times, that's in the tens place, plus 2 times, that's in the ones place, plus 4 times, that's in the tenths place, plus 3 times, that is in the hundredths place. Now if you want to, you could put parentheses around those values that are separated by the addition signs. You don't have to because order of operations says that you would multiply first anyhow. It's written like this with parentheses. Either one is fine with me. They're equivalent. All right, now I want us to do kind of the opposite here. I want you to go from expanded notation into standard form. Standard form just means numeric form. What is a number? So I would have a 4 in the 10,000s place. And then next to the 10,000s place should be the 1,000s place. And I see 2 times 1,000. Then next to the thousands place, I would have 100, right? The hundreds place, I don't see anything times 100. So do you remember what you put? Yes, you put a 0. And then next to that, I have the tens place, and I see a 3 times 10. Next to that, I have the ones place, and I see 5 times 1. Okay, now I'm getting into tenths and looks like thousands. I need my decimal point here, right? The decimal point separates the ones from the tenths. So here's the tenths. I see 2 times 1/10. Next to that, I would have hundredths. I do not see anything times a hundredth. That means 0. And then there's 2 times 1,000th. So that means my 2 would go in the thousandths place. Okay, word form. All right, remember, take it by chunks. So I see this first little chunk before the comma, that's the number 42. So I'm gonna write 42, and then what place is that 2 in? That's in the thousands place, right? So 42,000, comma. Now look at our next chunk, 35, and then that's 5's in the ones place, so we just get to say 35. This decimal point, what do I say? And, yep. And what do I have here? I have not enough room, which is okay. We'll just use this line here to write the rest of it. And, okay, now, to the right of the decimal point, the number that I see is 202. So go ahead and write 202. And 202 what? This 2 is in the tens, hundreds, thousands place. So 202,000 with the thousands. Right, that's all I want to do on page 50. Now, skip page 51, go to page 52. So we're on 52. The top of it looks like this, practice comparisons. We're just going to do a quick little practice. We're not doing all of these problems here, so scooch your paper down. Well, I'm scooching mine down. You just scoot your eyes down on your paper. We're going to do the ones that I have circled here. And remember, when we're comparing, just like when we compared fractions, we want the same denominator. When we compare decimal values, it's so much easier if they go to the same place, right? So with this is tenths, this is thousands. It'd be a lot easier if they were both thousandths. So you can make that happen, we learned, by adding zeros in. 7/10 is equivalent to 700 thousandths. So you can see there that those are actually equal. All right, now we're gonna do number 11. I know, we're skipping around. You can see the ones I have circled. Those are the ones I picked out to do with small groups today. For number 11, I see 2 places to the right. This only has 1 place to the right, so I would add a 0. And now I'm comparing 6 hundredths with 30 hundredths. 30 hundredths would be more. I know that 6 is more than 3, but this is 6 hundredths compared to 30 hundredths. Okay. Number 12, I see 1, 2, 3, and here I only see 1, 2. So I want them both to have 3. And now I can see I'm comparing 475 thousandths with 620 thousandths. 620 thousandths would be greater. Number 13, only 1 digit to the right, and this one has 2, so I'm going to put a 0, because 30 hundredths is equivalent to 3/10. 30 hundredths is greater than 29 hundredths. All right, we're going to go to number 14. I see 2 places and I see 3 places, so I need to put in that 0. And now I can see, oh, those aren't the same. This is 380 thousandths compared to 38 thousandths. 380 thousandths is definitely more. Now number 16, 1, 2, 1, 2, 3. I'm going to add a 0. Now we see those are both 380 thousandths. Those would be equal. Right? And then number 20. There's 1, 2, 3. Here's only 1, 2. This is the one all the time people say, oh, those are equal. When you put your third place in here, they're not equal. This is 111 thousandths, and that's only 110 thousandths. Although they're close, that one is still greater. All right, the check for understanding I do want us to do right now, because we just practiced this with our little mini lesson at the beginning of class today. I ask you to write these numbers from least to greatest. And that's what these signs mean. This number is less than this one, and this number is less than this one. So when you look at these, we said when we were doing our lesson earlier that if we write them with the same number of places to the right of the decimal point, it's easier. So I see 3 places here. That means I would like to rewrite this as that. And then this one I'm going to write underneath here. I would need to add 2 zeros after that. So I see that this has 34 ones. This has 345. This has 3. So actually, we didn't have to do that for this. We didn't need the same number of places to the right, because if you're looking to the left of the decimal point, isn't 3 less than 34 and 345? Yeah. So I put 3.456, and then the next lowest will be 34.56, 34 and 56 hundredths, and then the last, of course, will be 345 and 6/10. All right, we're done with page 52. Now I want you to look at page 53. So turn your page to page 53. This is not actually a quiz, okay? We're not gonna do it as a quiz, I should say. We're gonna do it like as a workbook page that we would do together for some guided practice. So first off, we have a comparison, right? Greater than, less than, or equal to. So with these, I see 1, 2, 3, 1, 2, 3. Which one is more? 105 thousandths is more than 51 thousandths. Here, it's a little hard to tell because this only has 1 place and this has 2. So when you put your extra 0, we see, oh, those are exactly the same. Right, number 3. Becca uses 100 beads to make a necklace. If 3 of the beads are red, what decimal number represents the part of the necklace made from red beads? So 3 out of 100 are red, right? That means I want to write 3 out of 100 as a decimal. That's 3/100ths. 3/100ths would be, yeah, I need a 0 in the 10th place. This would be 3/100ths. Right, number 4, what is the word name for the number? And I don't want to say it out loud right now. Why don't you try it and press pause and then see if you get it right? All right, I'm going to say what's to the left of this decimal point, and I see the number 46. 46, and then I see a big old decimal point, so I'm going to write a big old and right there. And then to the right of the decimal point, I see 901. 901, not 901. We already said our and. 901. And what place is this one in? Tenths, hundredths, thousandths. So I'm going to write 1,000 with a this. So 46 and 901 thousandths. Right, number 5. Write this number in expanded form using place values. So when I say to use place values, that's like saying expanded notation. So I'm going to write each place and multiply it by the place that it is in. So this 8 right here, that is in this is a decimal point, not a comma. That makes this ones, tens, hundreds. So 8 times 100. Again, if you want to do that, you can. You don't have to. This 2 is in the tens place, so 2 times 10. I'm going to have to do it now because I did it for the other one. Plus, I do not need to say 0 times 1. 0 times 1 is 0. But this 6, I do need to multiply by the place that it is in. It is not in the tens place, it is in the tenths place. Plus, that 8 is in the tenths hundredths place. And the 1 is in the thousandths place. All right, that's what it should look like. All right, keep it going. We're gonna turn now to page 54. I only want to do the very top number here. It says on page 54, what decimal would represent 87 correct answers out of the possible 100? So I'm asking you, what decimal is 87 out of 100? Well, that would be 87 hundredths. That means I need the 7 in my 87 to be in the hundredths place. That means I didn't have to put any zeros in the tenths place because the 7 already ends in the hundredths place. All right, we're not going to worry about 2, 3, 4. Okay, turn your page. And now we're on page 56. We're in the home stretch right now. Okay, so don't worry about this up here. We're going to just do these word problems. 14, 15, 16, 17. It says, write an equation, then solve. Tori had fabric that was 6.2 meters long. She used some and now has 1.45 meters, 1 45/100 meters. How much did she use? So she had fabric that was 6.2 meters long. She used some and now there's 1.45. How much did she use? That means I want to know the difference between those two, right? So I need to subtract. You should set this up as 6.2 minus 1.45. Okay, now if you wanted to, you could take lined paper and put it sideways, filling your numbers in so that the lines can separate your digits for you. If that makes it easier when you're trying to line things up, but these do need to be lined up. Okay, so now I see that I need to subtract, and I see that there is nothing above this 5. The cap did not want to come off. Nothing means 0. So I'm going to borrow from the 2, and now instead of 0, I have 10. 10 minus 5 is 5. I cannot take 4 away from 1. So I'm going to borrow from the 6, make it 5, and now I'm going to add 10 to this 1, so it's 11. 11 minus 4 is 7. Build your snowman, and 5 minus 1 is 4. So our equation would be 6.2, 6 and 2 tenths minus 1 45/100, and that equals 4 75/100 meters. That's how much she used. Now let's ask, does it make sense if she has 1 45/100 and she started off with 6.2? I would say that, yeah, we're fine, right? Okay, number 15. Matt is completing in the long jump event. His first jump was 3 56/100 meters. So far, the longest jump in the event is 4 200 meters. How much farther than his first jump must Matt jump in order to be in first place? Okay, so his first jump was 3.56. So far, the longest jump is 4 2/2. How much farther than his first jump does he need to jump to be in first place? So that means we want the difference between these two, right? So I'm gonna take 4 2/2 minus 3 56/100. We would subtract. Can you take 6 away from 2? Nope. And I can't borrow from this 0. That means I have to go all the way over to the 4. The 4 would become 3, and I'm going to give 10 next door. So that would be 10. Now I can borrow from that 10 to give to this 2, which it would be 12. So 12 minus 6 is 6. 9 minus 5 is 4. Build your snowman. 3 minus 3 is 0. So 46/100 is what you get. So we can write our equation. We just did 4 2/100 minus 3 56/100 and got 46/100 of a meter. But honestly, if he wants to be in first place, would that get him in first place? I guess it would be a tie for the first place. So to tie for first. All right, number 16. Patrick ran 53 meters away from Marty and then ran 16 2/10 meters directly back towards him. How far was Patrick from Marty then? Okay, so it says he ran 53 meters away from Marty and then he went back towards him 16 2/100. How far was he from him then? Well, you wouldn't add those two together, right? Because he ran away 53 and then came back 16 2/100. So we would have to subtract. So we're going to take 53 and we would subtract 16 2/100. Notice how I set this up. I have the 53 lined up with the 16 because this means the same as that, right? Okay, can you take 2 away from 0? Nope. So I have to go all the way over to this 3. I'm going to borrow from the 3. And now next to it would be 10. Now I have 9. Now I have my 10. So 10 minus 2 is 8. 9 minus 0 is 9. Build your snowman. I can't take 6 away from 2, so you can ungroup that 5. Give it to that 2. 12 minus 6 is 6. And 4 minus 1 is 3. So our equation would be 53 minus 16 2/100 equals 36 98/100 meters. And I think that's about all we'll be able to make it through in our small groups today. We're going to leave number 17. Thank you so much for working so hard.